The last paper to deal with is Zhao 2024. And the reason why this is a bit different is because this one gives you confidence intervals tabulated rather than differences. There was one of the other earlier papers that did that as well. The paper has 716 patients, so it's a very big study, 4 treatment groups: higher sensitive acupoints, so HSA, lower sensitive acupoints, LSA, sham acupuncture, which is going to be the control, and waiting list, so no treatment. That's not the control in this case. 10 dropped out of HSA, 11 out of LSA, 9 out of sham, and 3 dropped out of the waiting list. So the dropouts are very similar to each other. The values are given as means and confidence intervals. When I first processed this data, I made the mistake of thinking it was means and maximums and maxima and minima, and I ended up with the wrong values for the standard deviations. They should be comparable sizes to the values that you've seen before, so about 2, maybe up to 4. The best way of doing this, the formula for doing the confidence interval is the mean plus or minus the term from tables, so 1.96 because it's a 95% confidence interval and assuming normality, multiplied by the standard error of the mean. So the easiest way of dealing with that is to put it into an Excel spreadsheet. This is my spreadsheet for the Zhao data. So I'm looking at the before and the after. You put in the values of the means for HSA, LSA, sham, and waiting list for the different groups out of the paper. And then you can put the lower and upper bounds of the confidence interval. It doesn't matter which way around you do it. You can need the sample size because you're going to need to divide that by the square root, multiplied by the square root, to turn the standard error into the standard deviation. So the difference term is the difference, you can see it calculated here, is the difference between either the upper bound or the lower bound and the mean. This is 1.96 times the standard error of the mean. Once you've calculated that difference, you divide it by the 1.96, as the formula says here, and then you multiply that by the square root of the sample size to convert this standard error that you've worked out into the standard deviation. And the standard deviation is 1.46, 1.55, 1.52, 1.43. These are all very similar to the standard deviations you've seen in the other papers. You can also work out, while we're here and in the spreadsheet, because I put all the means in before and afterwards, I can work out the mean amount of change. And once I've got the standard deviations for the before group and the after group, I can combine them together using the usual standard deviation combination formula that I use for all of the other papers to create the standard deviation for the changes.